how to design the Turing machine for the language capital L equals to a power n b power n such that n greater than or equals to 1. So the language says it is a power n b power n. So equal number of a's followed by equal number of b's. So if there is 1a, there should be 1b, 2a's, there should be 2b's, 3a's, then there should be 3b's. 4a's means then there should be 4b's. So this type of string should be accepted by our Turing machine. So let us take this example and try to write the transition functions for this and then try to design the transition diagram. So we have 3a's followed by 3b's. So 3a's followed by 3b's. So Turing machine will be having one header. So what this header does is it will read the input symbol and it will just move one symbol to right, or it can able to move the header to one left also. So this is a read write header which reads the symbol and writes and moves one symbol one step ahead. So if it is in this particular position, it will either move one step left or one step right. So in this way, it will be keep on moving from left to right or right to left. According to our question, we should try to write a transition diagrams over this particular logic such a way that it should read and write properly and the state machine needs to be designed for this. Suppose if we see 3a's, 3b's, suppose let's see 3a's, 3b's, how we will able to identify there is equal number of a's and b's. We will able to identify when we check first a and first b. Done. Next second a, second b. Done. Next third a, third b. So like that we will check and we will tell right there are 3 a's and 3 b's. But here the Turing machine needs to identify that there are 3 a's and 3 b's. So from a we will directly jump to b and then we are telling that for 1a we have 1b. Next for second a we are just jumping and checking this a, this b. For third a I will check and I will jump to this one. But Turing machine will not jump from this a to this b. It will just move one bit ahead. That is one step ahead. Okay. It may either move from right to left or right to left. That possibility is there. But it can't jump from a to b. So what we have to do? When we read it, then it should read a, this a and this b. When b is done, I should go for the second a, then should go for second b. Means all the middle symbols should be read and written and then only it will reach the final destination, what is needed for that particular symbol. So after reading a, so we have counted there is 1a. So we have counted to represent that this has been read. We will replace that with the capital symbol, that is x. See, a has been read means a is counted. That is written as x. Read write header will read and write. But while writing, to keep track of what we have actually needs to be read and written, that is replaced with x. Okay. So a is replaced with x. Now I should check for the first b. So it will not jump to b. So it should pass through this particular input symbols. So now what's the step of the read write header? It will read write x and it will move to one step ahead. Okay. So now after reading a, it will write a. So it has been read and written same thing. Because this needs not to be counted. It will be just reading and writing. So let it be as a. Then it should move to the next symbol. So read write header, read a's and writes. It is counting this a. Then it is moving to write. This a as it is we should write because this needs not to be counted. We should count b for that a. So again move one step to right and a. Replace a with a only and move to right. Okay, read a, write a, read a, write a and move to right. Now I got the first b. For this a, I want this b. What we did, we directly jump to check this a to this b. But Turing machine has to move one step forward. Either it can move to right to left or left to right. Okay. So that's the case here. It is reaching to B. So whenever B reaches, then it is understood that it is matching with 1B. Now what we should do? We should replace this B with one capital letter. We will write it as Y. Means for 1A, 1B is matched. Okay. So for 1A, 1B is matched. Next, the rest thing will be written as it is. This is as it is in the tape. Now, I shouldn't move to right because now I want second A. Second A means the header should move to left. So it can't directly jump to this A. It should move one step to left. So it will be written as here. So header will be moving to left. It should reach this one. Okay. Now X, A, Y, B, B. Now it has been moved one step to left. Now we have reached here. For us, we can able to understand that this is the next symbol. But Turing machine can't able to read right header, can't able to identify that this is the next symbol. Until it reaches this, then it will identify that, okay, this is the end of that particular symbol. So we should move to right. So after reading this, again we should write it back. Okay. So let me show you here. X, A, Y, B, B. Here we are, right? Reading A. So replace that A with A and move to left. Here we can able to justify, but here it is not possible. So until it reaches X, then only we can tell that it has been end. So now move to right. Now it is moved to right. Now we have identified the second symbol. The Turing machine, now it identified the second symbol. Now replace this A with X. Now move to right. Same step. Move to right. Now how many A's, Y's, whatever are there, it will just read and write until it reaches the second B. So it is moving to right. Next. X, X, A. It is just reading and writing. Now it reaches to B. So from this we can able to identify this is the second symbol. So replace that B with X. Sorry, B with Y. Okay. So now this is done. What we have to do, we have to look for the third A. Right. So it should reach to this one. So X, X, A, Y, Y, B. Move to left means read all Y's, all A's, X and then move to right. Okay. So now X, X, A, Y, Y, B, move to left. Same thing here we can't say, Turing machine can't able to identify that is the last symbol. So it should reach X and then come back to this particular position. Okay. Now we are here. So we can't able to tell that this is the last symbol, not we, the Turing machine. Header can't able to identify that this is the last symbol. So it should move to left. So it will move left, read X, then only it will tell that that is the end of that particular symbol. Then it will move to right. Okay. So read X, write X, then move to right. Now this A will be read and counted as the third A. So that will be written as X. Now after reading A, we should check for B. So it will move to right. Next will be X, 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 Y, Y, B. Reading Y, writing Y. Until we reach B, it should read and write. So it is moving to right. Next is X, 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 Y, Y. Read Y, write Y and move to B. Now we got the third B symbol. So now what we will do? We will replace B with Y. X, X, Y, Y and Y. So this is the logic of designing the Turing machine for equal number of A's followed by equal number of B's. If you have 4 A's and 4 B's, you will get 4X and 4Y. 5 A's and 5 B's means 5X and 5Y. All capital letter says that that particular input symbols has read and counted properly. Okay. So if you check here, see we are checking this A and moving to B, right? Checking this A and moving to B. Until that all A's are just red. Once B is replaced with Y, we are moving back to X, right? So that is what happening. Again moving back to X, what is happening? We are coming back and checking for the second A, right? So second A, once we reach second A, again we will reach to B. Again we will reach to B. All A's and Y's are red and written, reaching to B, right? Replace B with Y. Then move back to A. So moving back to A, finally we reach X. So once we reach X, come back, third A we found. So replace A with X, then move until you reach B. So whatever Y's are there, just replace the same until you reach B. So finally replace B with Y. So in this way, the logic of the Turing machine will work. Now we will try to design the Turing machine, that is the transition diagram for this given logic. Okay. So at first, it is in state, whatever might be the automata, it will be at the initial state, Q0. So what is happening? Q0 on reading A, it is replacing A with X and the header is moving to right. Right? So Q0 on reading A, replacing A with X and it is moving to right. So same way we should write the transition function. Delta of Q0 on reading input symbol A. So we are replacing A with X, means some action is performing. So write it as Q1 and now A is replaced with X and after that what the header is doing, moving to right. So hope you understood this transition function. Q0 on reading A, replacing that with X and moving to right. Q0 on reading A, replacing A with X and state is also changing because A is counted. So it needs to be changed. So Q1 XR means header is moving to right. Now we have many A's. Until you reach B, all A's are red and written. So the transition function for this can be written as delta of Q1 on A. Remain in the same state because nothing action is performing. Read A, write A, read A, write A. Same action is performing again and again. So go to self loop, that is Q1. A is replaced with A only, right? See here, A is replaced with right. Sorry, A is replaced with A and moving to right. A is replaced with A and moving to right. So Q1 on reading A, writing A and move the header to right. State will be same because same task is performing again and again. So don't change the state. Okay. So the next one. Now where we are, see Q0 on reading A, replacing that with X. Whatever A's are there, we are just reading it and writing it, moving to right until we reach B. So where we are in state Q1. So delta of Q1 on B, delta of Q1 on B equals to, now we are replacing B with Y. So write it as Q2, B is replaced with Y. See now after B is replaced with Y, we are moving that to left. We are moving the header to left. After B replacing with Y, we are moving the header to left. So here we should write L. Okay. See, hope you will understand. Q0 on reading A, replace A with X. Some action is performing. So Q1. Q1 with all A's, it will be just reading and writing. So same state and move to right. Whenever we reach B, right? So whenever we reach B, replace B with Y and we are moving to left. So Q1 on B, change the state to Q2 because B is replaced with Y and move to left. Okay, now we have moved to left. So left means all A's should be red and written until we reach X. So same transition function we will write delta of Q2. What we are getting A, reading A, writing A. So Q2 on A, that equals to same action is performing. So Q2 reading A, writing A and we are moving to left. Reading A, writing A, moving to left. See here, reading A, writing A, moving to left. Until we reach X. So delta of Q2 X. So once after reading A, writing A, move to left, reading A, writing A, move to left. Once it reaches X, again we are coming from the beginning. Replace A with X, same action will be performed. So it should start with initial state again. So change the state to Q0. X is replaced with X only. And what we are doing? We are moving to right. So we will write R. See here. Q2 on reading X, changing the state to Q0 because again we are starting from the beginning. Reading X, writing X, move to right. See here, if you see this logic, we will understand. See, reading X and writing X, reading X, writing X, and we are moving to right. Fine. So reading X, when we have reached X, reading X, writing X, and we are moving to right. So again it is starting from the beginning. So we will write Q0. Q0 X and move to right. Now here we are. Where we are? Q0. Q0 on A, replace A with X and move to right. Same task that will be performed by this function. Q0 on A, replace that with X and Q1 XR. So same action will be performed. Replace A with X and move to right. All A's, Q1 on A, read A, write A and move to right. That function will be, task will be taken care by this one. Reading A, writing A and move to R. So when it reaches, now we have one symbol called Y because first B is replaced with Y. So Q1 should read and write Y and move to right until we reach the second B. Right? Reading Y, writing Y until we reach the second B. So Q1 should face the another symbol Y. So we'll write one transition function here. Delta of Q1 on A we have read. Right? Q1 on A we have read. We should write another transition Q1 on Y. Remain in the same state, reading Y, writing Y and move to right. So like how many A's we read and write, like that only that many Y's we should read and write. We are in state Q1. Q1 after reading B, replace that with Y. That function we have. Q1 after reading B, replace that B with Y and move to left. Same thing. Replace reading B, writing Y, replace that with Y and move to left. Reading B, replace that with Y and now move to left. Now how many Y's and A's are there? That should be read and it should reach X. Then we can go for the third A. Right? Until we reach the end only we can able to find out the third symbol. So read Y, write Y and move to left. Now we are in which state? We are in Q2. So for Q2 also we should write one transition function. Q2 Y, read Y, write Y and move to left. Same Y's will be reading and writing. It will be moving to left. Q2, we will get A's, read A, write A and move to left. Finally, we will reach X. So read X, write X and go to the state Q0. So like that it will happen. Read A, write A. So Q2, read A, write A, move to left. Q2X. Read X, write X, move to right. Now we are in Q0. Again, same function will be performed. That is Q0. Q0 on A, that equals to Q1X R. That is replace A with X and move to right. Now Q1Y. How many Y's are there? That will be read and written and move. How many A's you will get? Y's you will get? Just read and move to right. Once you get B, replace B with Y. When you move to left, see, when you move to left, then how many A's you will get? Read it, move to left. How many Y's you get? Read it, move to left. When you get X, then start from the initial state. Replace X with X and move to right. Look for the next input symbol. A. So here the same thing happens. So read Y, write Y, move to left. Now we got A, right? Read Y, write Y, move to left. See here. Now read A, write A, move to left. X we got, read X, write X and move to right. Again we are starting from the first symbol. Now read A, write X, move to right. Now read Y, write Y. Now how many Y's are there? Just read and write and move to right. This one will work. Q1 Y, read Y, write Y and move to right. Now finally I got B, replace B with Y, replace B with Y and move to left. So finally we are here. Right? So it's moving to left. All Y's are red. So read Y, write Y. Move to left. Here we are. Next, read X, write X. Move to right. Now we should move to right. So from here, we are changing the state to the next path. So we should write one more transition function here. So from Q naught, that is delta of Q naught on reading X, replace X with X and change the state to Q3X and move to right. Means replace X with X. Now we don't have A. So it should be moved. Just replace X with X and moving to right. We are going for Y. Okay. Next one more transition we should write delta of Q3. What symbol we got? Y. So read Y. Change the state to Q4. Read Y, write Y and move to right. Next will be delta of Q4. Same task will be performed. Read Y, write Y. At the end we have a blank symbol. So read Y, write Y and move to right. So Q4 on Y. Same task will be performed. So let it remain in the same state. So read Y, write Y. Read Y, write Y and move to right. Okay. Next step. So after reading Y, writing Y, move to right. Finally we will get B. B represents the blank symbol. So delta of Q4 reading B, that equals to Q4. So we are reaching to the last state. So we'll write Q5. Replace B with B only and we will be in the halt state. So these are the transition functions. What we got once we have applied the logic of applying this Turing machines over this particular logic, we got these transition functions. Okay. So now we will try to design a transition diagram for this type of function. Okay. So now let's start with the first transition function. What is this? Q naught on A is Q1 XR. So first we will try to design the states Q naught. Q naught on reading input symbol A going to the state Q1. Going to the state Q1. Q naught on reading input symbol A going to the state Q1. A is replaced with X. Right? A is replaced with X. So A is replaced with X and it is moving to which direction? R. So we will write it as capital R. Next, Q1 on reading A, writing A, moving to the state. It is in the same state Q1 and moving to right. So we should put a self loop. So reading A, writing A. See here, reading A, writing A. So reading A, replacing that or writing that with A and we are moving to right. Reading A, writing A, moving to right. Next Q1, remaining in the same state. Read Y, write Y and move to right. So next one will be read Y, write Y and move to right. Next Q1 is reading B, moving to the state Q2, replacing B with Y and moving to left. So Q1 is going to the state Q2. So reading B, replacing that with Y and it is moving to left. Right? B is replaced with Y and moving to left. Same thing I have written. Now, again next transition is Q2. Whatever A's we will get, read A, write A and move to left. So it remains the same state. We will put Q2 self loop, read A, write A and move to left. Again, we will be getting Q2 X. So whenever it reaches X, change the state to Q naught, replace X with X and move to right. So Q2 moving to the state Q naught. Right? So what action is happening? Reading X, writing X and moving to right. So X is replaced with X only and moving to right. Okay, this is done. Now Q2, reading Y, writing Y, moving to left to the same state, Q2 only. So one more label we are getting, reading Y, writing Y, move to left. Now Q0 on reading X, going to the state Q3, reading X, writing X, replace that with R. So Q0 going to the state Q3, reading X, writing X and move to right. This transition function. Reading X, writing X and move to right. Next Q3, reading Y, writing Y, move to right. State is changed. So go for Q4. Reading Y, writing Y, move to reading Y, writing Y, move to Q4. Now Q4, reading Y and writing Y. So same, many Y's will be there, reading and writing and move to right. So reading Y, writing Y. To the same state it is going. So reading Y, writing Y, move to right. Okay. Until it reaches the final state. So hence this Q4 becomes the final state. So finally it is reading X, writing X, reading Y, writing Y. It will reach to the end and it will be ending up with this. Okay. So this is the transition diagram for a given Turing machine. Right? So we hope you understood. Let me show you this. See, replace A with X and we are moving to right. So replace A with X and moving to right. Whatever A's or A's we encounter between A and B, that will be read and written. Once we get B, read B and write Y and move to left. So in left we will get again A's, read A, write A and move to left. So whenever we get X, then we will understand that is the end of the string. Then again start with the second A, replace A with X. Next we will get A's, replace A with A and move to right. Some B's are replaced with Y. We don't want this, we want B. So all Y's are also read and written and move to right. Now if we get B, then replace B with Y and move to left. So if I have A and B, A is replaced with X. See here, A is replaced with X and moving to right. So any number of A's are there, read A, write A and move to right. So once I get B, replace B with Y and move to left. So left means I am getting two A's, read A, write A's. And once I get X, then replace X with X and move to right. So this will be written here. Don't worry about these things. So now I am again going for second A. Replace A with X. All A's will be read and written. Now Y is also there. I want this one. This should be just read and written. So read Y and write Y, move to right. Okay. Next if I get B. B means replace. So here we are. Replace B with Y and move to left. B with Y and move to left. Here we are. So all A's, all Y's should be read and written until I reach this X. Right. So for that reason what we should do? Read Y. See here. Read Y, write Y, move to left. So read Y, write Y, move to left. Read A, move. So that's why read A, write A, move to left. Read Y, write Y, move to left. Once I reach X, then read X, write X and start from the beginning. Then we will go to the third symbol. X. Replace A with X. Then all Y's, we have Y's here. All Y's should be read and written. Read Y, write Y, move to right. Read Y, write Y, move to right. Read Y, write Y, move to right. Now I got B. Read B, write Y, replace B with Y. So now we are here. So finally we are here. So whatever Y's are there, that should be read and written. So read Y, write Y, move to left. Read Y, all Y's. Read Y, write Y, move to left. Now we will come here. We will come here, X. So read X, write X. So this will happen. Read X, write X, move to right. Now we move to Y. Now we have that many number of Y's should be read and written. So first we are changing from X to Y. So change the state from Q3 to Q4. So read Y, write Y. Now all Y should be read. So we will make a loop here. So read Y, write Y, move to right until we reach the halt state. So this is the transition diagram for the language A power n, B power n.